Hello all. I've got what should be a short video today explaining how to run a function in parallel when that function you're running is problematic. It's something that came up when talking to a coworker this morning, so I thought I'd make a quick demo on how to make it work, or how to make those kinds of parallel loops work without much extra code. So the demo that I have here is very straightforward. I've got an example function up towards the top that fails under one certain special condition. If I give it a certain input value, it throws an error. There are many functions like this. I made one that's stripped down to illustrate the example of what happens when I try to run a series of inputs with that function in parallel using a tool like Processable Executor or Python's similar but older multiprocessing library. What happens if you call this using a conventional like pool.map or executor.map approach is that it will fail because if any one instance of that function fails when you're trying to run many inputs across and in parallel, that entire loop fails. So what we do instead is submit in two parts. The first of which is submitting your function with many different inputs and then storing a future. A future is a type of Python object. It's similar to a pattern used across many other languages that doesn't hold the result, but it holds a promise of where to find that result when the calculation has completed. So what I'll do is take that promise and I'll loop over all of them and find the ones which fail with an exception. I know that happens when this .exception function returns with something besides a none, and if that exception happens, I return none for the value, which could be a suitable placeholder. If not, I return the actual result. So let's take a look at what this looks like in practice. Alright, so here I've run my function. You can see here that for the first input I returned a none because that one failed. And I know that by looking at my futures, which is a list of the states of each of these computations I submitted. And you can see for the first one it finished and raised an error, whereas the other ones finished and returned a float value. So let's take a look at the exception. I can see that it raised the exception that my example function had, and if I try accessing the result, it will throw that exception. So if I'm running code and I want to use some kind of try except block, like let's say I have something that can perform different kinds of error handling, like let's say can throw more than one type of error, I could do this. Oh, well, it looks like I didn't do my spelling right, but you get the idea. With this kind of passing forward of exceptions and being able to look at whether an exception was returned, I can write error handling code, just like in the simple example that I use that said if it fails, just use a none instead of the actual value. So that's all for today. Hopefully you'll find this helpful.